Hello students, let's move to the another session in the distributed systems. This is Google File Systems, GFS. Then we will be knowing about the Sun NFS, Sun Microsystems developed SNFS. Okay, so now we are going to see GFS in detail. So GFS is nothing but we are going to see how the Google file system will be saved internally, right? So here the Google file system will be having the clusters of your data. See here the clusters indicates that every cluster will be having a file data. See, one file will be divided into n number of chunks, and all the chunks will be having a content called as the metadata of about all the chunks will be available in the master content. So this master server will be having the access to all the chunks available internally, right? So this is nothing but we are going to divide your file, GFS file, into number of chunks, and this division will be dependent on the file size. So where every file size will be having 64 megabytes of the storage, MB data, 64 MB of data will be having in every chunk of the data, and these chunks will be divided into the distributed system and across the network. Every chunk will be called as a chunk server, because every server which is holding a chunk of that particular GFS system will be called as a chunk server over there, right? And the address of all the chunks will be available in the master chunk. Okay, so this master will be responsible for where this chunk is located. After this chunk, to which chunk we have to move. So all this will be available in the GFS system. And now GFS client passes a file name and chunk index to the master. Okay, so nothing but GFS, whoever the client who needs a particular file will be passing the file name, right? And the index to the master. So which chunk I need, that index I'll pass to the master. So this master will be responsible to give your data whatever you are asking by giving by checking your chunk in n number of chunk servers, and then you have to reply back to your client. Now this is a basic cluster based distributed system where GFS client is asking for a data with the file name and the chunk index. I said just as a file name and chunk index. So from here the master will be searching for the chunk where the chunk is exactly available. Okay, so from here the master will be replying back with the contact address. See, to where we have to contact with the contact address. So with the contact address with the chunk ID and the range, client will be again coming to the chunk server directly, and from here it will get the data back. So this will be taking place in the Google file system. So this we have to analyze, and very important topic where we are going to know how the Google file system will be taking with n number of thousands of terabytes of data, right? So now here this is a Google file system. Now Google file system will be having the n number of servers over there, and these are the chunks available, right? To one particular file we are saying these are few chunks, and file 2 few chunks, and file 1 to read content again we have few chunks over there. And all the servers we call as a commodity servers, so where all the servers are in the cluster, right? Now the commodity hardware what we need here is a servers content and the bugs. Operating systems wise we should know about all the human errors and the operating system bugs over here, the design considerations. Now the large files we will save in the commodity servers, because this saving in the commodity servers is very cheaper, right? Next, file operations, maximum we can go for read and write operations, right? So append is also having the write accessibilities also, but appending will be like just adding some content. No random writes. See, where we can ask for one particular file to be updated is okay, but to write overall data we need to have the whole access of that, even though the reads can be done at any moment. See, coming to the chunks here, each chunk will be having 64 megabytes of data as we have just discussed. And if you can see, this file has been divided into 4 chunks here, and 4 chunks distributed across the network and saved in the chunk servers over here. These are the multiple machines, we can say. And replicas, see, every chunk again I am going to have its replica somewhere, C3 here, C4 here, C2 here, right? So because if this particular server, chunk server fails also, our data will be available somewhere in the network, right? So this is very important to know. The replica plays important role, right, all the time. Now, who is GFS master? The GFS master is the whole and sole responsible for this chunks, and this is a mediator between your client and your chunk data. GFS will be holding the metadata of the chunk but not the exact data of that particular chunk, right? So where your data may be available, the metadata, I mean the range, address kind of things of the file name, all this will be available in the GFS master, but not the exact content of that particular file, right? So file names, chunk IDs and chunk locations, access control details will be available in the GFS master. So this also we should know about this. What are the contents of GFS master? Now GFS master having this content, right? Now when client communicates with the GFS master will reply back to the client saying that you have to contact this chunk with the range of this one and the location is this one. So the client will be connecting to that particular chunk immediately. Now read operations, as we are just discussing, right? File name and chunk. Now the master will be taking some time process to analyze where your chunk is available. Now it will give the location where to handle, and you will come there and you will read the content, right? So this is about the read. Now coming to the write operations, it is very hectic, and if it is okay, it is very easy to understand. See, client will be asking for where the locations are available to write, okay, with the file name and the IDs, right? Next, the master will be responding back. Now from here, the client will be directly proceeding with the chunks, right? So by the time of the proceedings, it will also go with the proceeding with the main replica, where the primary replica is available and where the secondary replica is available. Now from here, the replica will contact to the its secondary storages, so where your data is available. So from there, it will give back your data to the primary replica. From the primary replica, my client will be getting the data, and we can update the data wherever we require. Heartbeat. See, this heartbeat concept is very simple, like 1 mark question. So these heartbeats in the chunk servers are very, very important to know your chunk is alive or not. Something has happened to your machine, I mean the crashing, some kind of things. So if you can give this heartbeat message to the main server master all the time, so we can understand that my particular chunk server is alive. Next, replica count. So we have to check every time, we have to take care of if any chunk server downs, you have to take care that my chunk server is down, right? So then at that moment, what about this replica, is it available or not? All these measures to be taken care. All the time, all the chunks count must be same, right? C1 2 times, C3 2 times, so like that. If C1 is only 1 time, its chunk server has been failed, right? Next, so taking care of your chunk server 2 and 2, right? Next, this is also okay, 3 and 3. So replica count is 3 over there, right? And yeah, single master for multi TB cluster. See, this is very simpler. If we have terabytes of data, how clients, I mean the clusters are very large, then we should have a client who is asking for the data all the time. So just now we have discussed, right? We have a master where we will be having the metadata over there. So single master, we say this has a single master holding all the chunks as a multiple TB clusters, right? Now we can have a master holding the operations log also as a metadata, because it will be like a checkpoint kind of thing where you will be having all the backend threads, what are the executions taking place, and if any master crashes, so this operations log will be helpful to us to analyze. I mean, the new master will be available right immediately, so that rebooted master will be having all the logs data over there. So operations log is very important to have a look of all the taken history of your chunk data, right? And the shadow master, see, as we have just said, that if a master crashes out, if a master is down, if operations log is obviously available, but we should have a copy of it, right? So for that we have a shadow master who will be taking care as a background of your exact master. So operations log also will be having a replica over that in the shadow master over there. So this is all about Google file system. If you have any doubts in this, please be free to contact any time in the college. Thank you.